So hopefully you know a little bit about scientific notation from work in science class. So we're going to go over the basics fairly quick and then kind of get into what we need for math. So let's start with a giant number like 201 million. And, I can write it real easily, but it's not really easy to work with if I need to multiply or divide that by something. So what I do is I find the decimal at the very end, because that's usually where it is, and I move it in so that there's only one number in front of the decimal. So 1, 2, 3, 4, 5, 6, 7, 8 places is how far I moved it for this number. So I have 2.01. I can stop after the last digit that is a not 0. And then I do times 10 to the however many places I moved it. So in this case, I moved it 8 places. So I do times 10 to the 8th. So see if you can move, or we'll do this one together as well because it's going the other direction. But see if you can kind of figure out what we're going to do. So we have 0.000051. So now I'm moving it the other direction because the non-zero digits 5 and 1 are over here. So I'm going to move it 1, 2, 3, 4, 5 places. So I get 5.1 times 10 to the negative 5th because I did move it to the right. So if I already have a decimal and I'm moving it right, I'm going to have a negative exponent, versus if I'm starting and I'm moving it left in to make the number for a bigger number, I'm going to have a positive exponent. So hopefully that's kind of what you have for a knowledge base of scientific notation from science. We're going to talk today about multiplying with scientific notation, and then eventually with dividing scientific notation. Come on. Okay. So let's say I have 3.5 times 10 to the negative 3rd and 7 times 10 to the 5th. Well, I could go ahead and write out the decimals really large, or the numbers really large, and multiply them with lots of zeros and that kind of stuff. But that seems like a waste of time if I can work with smaller numbers much faster. So the first thing I'm going to do is I'm going to multiply the whole numbers. Because 3.5 isn't necessarily a whole number, but I'm going to multiply the things with some significant digits. So I'm going to multiply 3.5 times 7. And when I multiply with decimals, if you'll remember, I move this decimal out and I count however many places I moved it out. So 1, I moved this one 0. And then I can start to multiply. 7 times 5 is 35. Carry the 3. 3 times 7 is 21. Plus 3 is 24. And then I move my decimal back in 1, because that was how many places I moved it out. So there we go. And then I know when I have the same base, I can add the exponents. So I have negative 3 plus 5, which is 2. So I have 24.5 times 10 to the second. And that's mostly a good answer. Except for, remember with scientific notation, we want the decimal to be, we only want one number to be in front of the decimal. So I really need to move this guy one more time so that I get 2.45 times 10. And because I moved it an extra one, I'll add that one up here. we'll have 10 to the third power. Okay? So I'm going to have you try this one on your own. 6.5 times 10 to the 12th times 8.7 times 10 to the negative 15th. So go ahead and try that on your own, and I'll work it out in a sec. So if I multiply 6.5 and 8.7, I move the decimal out one place for each of those. And when I multiply the 7 through, I should come up with this. Then I multiply the 8 through, adding my zeros in where necessary. Get that. I add down 5, 5, 6, 5. And because I moved it out 2 places, now I must move it in 2 places. So I have 56.55. Then I add my exponents. 12 and negative 15 would give me a negative 3. So I have 56.55 times 10 to the negative third. But remember, I want to move this decimal in one more place. So I get 5.655 times 10. I moved it plus 1 in. So negative 3 plus 1 would give me the negative 2. And that would be my final answer. Okay. So just like we can multiply with scientific notation, we can also divide with scientific notation. So let's say I start with 3.066 times 10 to the 8th over 7.3 times 10 to the third. I'm going to use much the same process. I'm going to divide my numbers first. And then because I'm dividing, I'll subtract my exponents down. So we'll go ahead and start by dividing. So I'll have 3.066 in the house and 7.3 at the door. Remember, with dividing decimals, if I have a decimal at the door, I need to move it over one, which means I need to move this one over in the house one. And then I raise the roof. And now I can kind of divide normally. And I say, how many times does 73 go into 30? 0 times. How many times does 73 go into 306? Well, that goes in 4 times. In fact, it goes in exactly 0.42. Yep. So I have 0.42 times 10 to the 8 minus 3 would be to the 5th power. And that looks fine and dandy, except for one thing. I need one number in front of the decimal. So that means I have to move this decimal place over here. And because I moved it to the right one instead of to the left, instead of adding 1, I'm going to subtract 1. So now I have 4.2 times 10 to the 4th power. Okay. I'll let you try this one on your own. 9.6 times 10 to the 3rd over 1.2 times 10 to the negative 4th. Go ahead and try that. So if you follow the work carefully, you should get 8 times 10 to the 7th, and there's no need to move any extra decimals because we get a whole number 8. The only thing to really watch is your integer operations. When I do 3 minus and negative 4, the minus and negative both becomes positive, and so I have 3 plus 4 is 7. Thanks for watching.